Okay. So key features of functions, we're going to start off by talking about what is interval notation. We have looked at these things graphically in math classes before. We've looked at them, how to write them as an inequality, and today we're going to expand on that. So if I come up with like a number line graph here, let's say I've got a closed circle on 2, and I've got this part of the number line shaded. Now, some teachers shade on top of the line. You could also see this with it shaded above the line. You are free and welcome to do whatever one works for you, but they have the same meaning. So graphically, when we're talking about an interval of a number line, we could say something like all of these numbers that is 2 and all the number and everything bigger than 2. When we write that as inequality, we use a variable. X is greater than or equal to 2. Okay, so that's all the numbers that are larger than 2. And I have or equal to because I'm including 2. All right, so back to that idea of having an open circle and a closed circle. New interval notation. Interval notation is going to say from here to here. So this is from 2 all the way to the right. This just keeps going and going and going and going and going to infinity. So for interval notation, I'm going to have a square bracket, a 2, comma, infinity, and a round bracket. And I'll go through and explain all those pieces. Maybe you've seen interval notation before, maybe you haven't. It's technically not a part of the Math 2 book, but some teachers do introduce it because you're going to get it eventually anyways. So this says the numbers from 2 to infinity. Now, the square bracket means it includes the number. Bless you. A round parenthesis means does not include the number. Anytime we're using the infinity symbol, it's always a round parenthesis. Because this number is approaching infinity, I can never actually reach infinity, so I can't include infinity. Infinity is not a number, it's a concept. There are different sizes of infinity, which we will talk about at some point during the year. So this bracket here means that I include the 2. Come up with another small example. So you have a number line, and I'm talking about the numbers between -4 and 8, including 8. As an inequality, I would write that x is the numbers between -4 and 8. -4 is an open circle, so it's going to be less than, not, or equal to, because it doesn't include that number. 8 is a closed circle, so this will be or equal to. The underlined inequality, the or equal to, is going to correspond to that square bracket. So now for my interval notation, I have the numbers between -4 and 8. But -4 is not included and 8 is included. Questions on any of that? Yes. So included would be like, do you remember when you would study these open circles and closed circles? When open circle would be like, this means all of the numbers close to -4, but not -4, right? So this would be like -1, -2, -3, -3.5, -3.8, -3.9, -3.99, but not -4. So if it doesn't include that number, then I use this round bracket to say the numbers go all the way up to -4, but don't actually include -4. Now, if the number comes to 8, but I actually touch 8, 8 is included in my interval, then I use this square bracket to show that, yes, 8 is part of the solution.
So open circle is not included?
Yes, open circle is not included. Perfect. Here, maybe this is a good note. Open circle. Closed circle. Nope, that's backwards. Mer, 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 mer. Does that make it more clear? Okay. Sweet. Thank you for asking. All right, so now we've got this cool chart here. And some of these features are review. We've seen them before. And some of them are going to be new. Domain. All right, what is domain? Domain is the set of all input values. The input is also called the independent values, or the independent variable. This is usually x. Now for this class, x and domain are going to be very closely related. When you go into calculus, the domain can be a lot of other things. A lot of what we're doing today is we're talking about intervals, but we're also going to be talking about points and figuring out the difference between them. The domain is a set. It is an interval of the x values. So I want to look at this graph and imagine that I take it and I smash it onto the x-axis. What are all the x points that I hit? Well, this I would hit 1. I'd hit everything in between. I'd hit 2. I'd hit everything in between. I'd hit 3. I'd hit everything in between. And 4 I wouldn't actually touch, right? Because that's an open circle if I smash this down. So I've got 1 and then down to 4. So in interval notation, the domain is going to be from 1 to 4. 4 is a round parenthesis because it's not included. I have an open circle at that point in the graph. Conversely, the range is the set of all output values. These are dependent on the independent value, and the range is usually y. So now try to imagine what values get touched if I take this graph and I squish it to the y-axis, right? If I just accordion this all in, what do I touch? Well, I'm going to touch here at -1. I'm going to touch the here, right? Even though -2 doesn't exist on the very right-hand side of the graph, it does here, so that's going to be continuous. And then it's going to touch at 3, but it's not going to keep going, right, if I move that over. So I've got from -1 to 3. And I have to choose the correct brackets. -1 is included. And it looks like 3 is also going to be included. These are intervals. This is a set of a whole bunch of numbers. Yes. Because it looks like I touch it right here. Right? If you were to talk about points that this graph touches, you'd probably say that 3, 3 is part of the graph. So when I move that over, I touch 3. Yeah. Okay. Another familiar concept, x-intercepts and y-intercepts. X-intercept is the point or points where the graph crosses the x-axis. This occurs when y is equal to 0. We'll always operate on what we can see in the graph. Now, I can only see this small window. The x numbers are from -3 to 5, right? I don't know what happens after here. It could do something else really weird over here, but I'm going to assume that I can see all critical parts of the graph, all right? So that assumption means that this is going to continue to come down, 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 down forever and continue to go up, up, up forever. If the graph were to stop and not complete to the end of the window, then we would assume the graph stops. But as long as the graph continues to go to the edges of the window, we assume it goes on, which is why when you're doing your graphs, it's important that you continue your graph to the edge of the window and not just give me like a little piece of it. So points where the graph crosses the x-axis, here, here, and here. points are just coordinates. So this first coordinate on the left-hand side, the x value is -2, the y value is 0 because I go up or down 0. So this is -2, comma, 0. I'm going to separate my answers by a comma because that's what the online homework asks me to do. So practice it here. Then I hit the point 1, 0. And then 4, 0. Whenever you're talking about x-intercepts, the y value should be 0. Conversely, the y-intercept is the point or points where the graph crosses the y-axis. This occurs when x is 0. So I'm looking for the coordinate on the graph where it crosses the y-axis. In this picture, it only crosses the y-axis one time. And the coordinate of that point is, remember, x comes first, so left or right, 0, and then up 2. We will be writing intercepts as coordinates. Part of the challenge of this section and what we're going to talk about moving forward, because we're going to talk about this for a lot of different kinds of functions, is without using context, an interval and a coordinate can look the exact same. So for this first one, I had a square bracket and a round bracket, but if one wasn't included, this would be a round bracket, and I'd have from 1 to 4, which is an interval that doesn't include 1 and doesn't include 4, which looks a lot like a coordinate, but they are different things. This is a series of points. This is one coordinate. So making sure that you're understanding what it's asking in context and answering appropriately is important. Again, this is an interval. So it's the possible x values. And then this is a point. This is a coordinate. This is a location on a map. See how it can be confusing, right? They're going to look like really alike. Now, if I have a square bracket, automatically that's an interval. But sometimes if I have two round brackets, you're like, what is that? Okay. A function is positive on the interval where the graph is above the x-axis. As a rule, when asked for an interval, we're talking about the x values. The only exception is the range, which by definition is the y values. Everything else is going to be the x values. So I'm looking for the interval where the graph is above the x-axis. Kind of purpley. So if you like to use pens or markers or highlighters or something, that might be helpful. But I'm going to highlight where's the graph above the x-axis. So here's my x-axis. I'm just going to talk about the stuff that's above it. So I'm going to highlight it. My highlighting tool. That part is above the x-axis, and this part is above the x-axis. This is -2, this is 1, and this is 4. And we're going to name those intervals. So this portion is above the x-axis. It starts at -2 and goes to 1. It's an interval from here to there. Now, when I'm talking about things above the x-axis, that's not going to include this point -2, 0, because that's neither above or below. That's neutral. So because it doesn't include this point, I have a round bracket or a round parenthesis. Same thing here. Right? Above means it doesn't touch the line, so it's going to be a parenthesis. That is an interval, even though it looks just like a coordinate. The other part that is positive is going to start at 4, and it keeps going forever, right? Well, we can assume that goes to the right forever and up forever because I can't see any more of the graph. So this part of the interval is going to be from 4 to infinity. It doesn't include 4, and it can never include infinity. So we have this symbol. It looks a lot like a U. Sometimes it's a little flatter on the bottom, but it's like a big U. And it means union. Well, it's called union, and it means and. So my answer for where are the intervals where the function is positive, from -2 to 0 and from 4 to infinity. Oops, I read that as 0. From -2 to 1 and from 4 to infinity. Where is the function negative? At the interval where the graph is below the x-axis. Increasing is going to be when y is increasing and x is increasing. Okay, I'm going to give you a little bit of time. I know we're new to this. You have an example above. I would like you to take a little bit of time and try to write down, all right, do it in pencil so you can erase, or if you don't mind crossing out, do it in pen. Write down the interval where the function is negative. Go for it. Try to fill in this box. It's okay if it's not right. Give it a shot. All right, here we go. Here's the answer. Check it out. Maybe you got part of it right. Maybe you got all of it right. Maybe you didn't know. That's okay. It is not, actually, because it has to go from least to greatest, right? If I say we're at school from 7:40 to 2:46, it's a lot different than if I say we're at school from 2:46 to 7:40, right? Very different. You're like, dude, I do not want to stay here for 15 hours. Okay. Yes. If you did this over here and this over here? Yeah, that's fine. But you can't swap them this way. This interval has to be smallest to largest, smallest to largest. But if you wrote them in a different order, that would be fine. Always smallest to largest, right? Just like if you were talking about time or dates. Order matters. Cool? Okay. Now, next concept. Function is increasing and the function is decreasing. Okay, so talking about function increasing and decreasing is you can think about when you talk about increasing and decreasing slopes, that perspective will be helpful. I'll give you a little bit of time to write it down. So a function is increasing if the y values increase as the x values increase. So think about as you're going to the right, the graph's going up. Whenever I read a graph, just like I read a page, I always read left to right. So you can imagine like, I don't know, like a little computer character, right? If they're walking on this path from the left to the right, they're going down, 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 up, 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 down, 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 down. The up, up, up part is the increasing part. So my increasing would be from here to here. We got some people taking physics this year?
Yeah.
Yes, that was my favorite class in high school. Yeah. Okay. Now, when I'm talking about changing direction, I'm going down, and then when I get to the minimum, right, this is a neutral spot. I'm going down, 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 down. I stop, I change direction, and then I'm going up, I stop, I change direction, and coming back down. So it does not include this minimum point or this maximum point. So here, remember, I'm always talking, when I'm talking intervals, I'm always talking x values. So this is going to be -1 to 3. Right? Imagine in your head like smashing that onto the x-axis. What are the x values when this graph is increasing? -1 to 3. Does it include the point when x is -1? No. Does it include the point when x is equal to 2? 3? No. So I have round parentheses. So decreasing is just going to be down to the right. So same thing, if I'm walking this path from left to right, I'm going down, 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 up, 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 down, down, down. I want to know where's the graph decreasing. I'm going to pause for a few seconds, see if you can write the interval. Or intervals. All right, little self-check. Let's see how you did. This is going to be from -infinity to -1 union 3 to infinity. Go pretty good? Maybe. Yes. All right. Next concept. Maximum and minimums. Now, there's different ways to describe maximum and minimums. There's absolute maximum and there's relative maximum. In this case, absolute would mean the highest number one point on the graph. Relative would mean like any time it changes direction. So this definition is going to fit the latter. A maximum of a function is going to be a point where the graph is the point where the graph changes from increasing to decreasing. Anytime I hit the top of a hump, that's going to be a maximum. Now a maximum is a point. It's not an interval. It is a one location on the map. Now these coordinates don't line up perfectly with whole numbers. It looks like I've got -3.5 and maybe up a half. On your Pearson homework, when you're listing multiple coordinates, they ask you to put a comma there. It'll give you a reminder on there. And then the next one looks like just 2, 4. Minimum of a function is just going to be the converse. So the graph go decrease, decrease, down, 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 down. Stop, turning point goes up. That's a minimum. Goes up, comes back down, goes down, and then up, down, and then up gives me that minimum value. So let's see, that looks like to me -2, -1, and that is like 2.5 and up 1 and I don't know, 1.75 or 1.8 or something. Looks like more than a half. It's a pretty big estimate, but yours might be a little different and still the right answer, and that's okay. All right. Last new concept, the average rate of change on an interval. When you're thinking about this, you can think of you're finding the average rate of change between 2 points, which is just the same as using slope. They just may or may not fall. Your graph may or may not fall on a slope style line, on a straight line. So this is slope of the line segment between 2 points. And it may have been a minute since you've done slope. Slope is the change in y over the change in x. There's supposed to be 2 points that are marked on your graph. I think I made yours bolder before I made copies. Hopefully you can see them. So basically the average rate of change of this graph over this interval is just the slope between these 2 points. So you could even draw this line in. And I'm going to name these points. Let's see, what is that? It's -4 up 7. This is over 3 up 2. I'm going to name one of these points 1, x1, y1, and one of these points 2, x2, y2. It doesn't matter which order you go in. All right, so then when I subtract, let's see, I've got y2 minus y1 divided by x2 minus x1. So I'm gonna put up an example. We're gonna work through the whole thing. I'm gonna give you guys a chance to answer the questions first. But I'm gonna start you off because some of the problems on our Pearson homework ask you to graph. So back on your graphing notebook, it's going to ask for this laundry list of information. So we're going to do all these pieces for one problem. I'm going to show you some things on Pearson and then give you the rest of the time to work today. Okay, so before I want to find all those details, I definitely want to know what this graph looks like because I don't want to do this, try to do it in my head. I definitely want the visual. So I have f of x equals 2 minus the absolute value of x. We just practiced graphing these. Hallelujah. This is what they throw you into the very first section in Math 3 and don't give you a review. So we reviewed for 2 weeks. Hopefully you find it helpful. I want to write this in the same format we've been using so I know what the graph looks like. To do that, I'm going to move that 2 to the end. So I'm going to have negative absolute value of x and the plus 2 at the end. That's the format we've been using. So I'm just going to scoot that on over there. And then tell me anything you know about this graph, even if it's a small little detail. What do you know about this graph? Yeah. It's a V. Yes. Great. What else do you know? It's going to open down. Yes. Anything else? Two is the y-intercept. Yes, it's going to go up too. You guys are awesome. It's exactly right. So I've got all of these things, right? It does go up 2. So instead of my vertex being at 0, 0, it's going to be at 0, 2. The slope of this is going to be 1 because I don't have any other numbers in front of x or in front of the absolute value. But it is going to open down, and it's shaped like a V. So I'm going to go down 1, over 1, down 1, over 1, down 1, over 1, down 1, over 1 in both directions. Try to fill the window of the coordinate plane that I created. So I'm going to pause there. I want you to work to fill in as much of these things as you can. So if you can't get them all, that's fine. We're still working through, we're still learning. But go through these, right? These are review concepts. It might be a little easier. These are newer concepts towards the bottom, might be a little harder. Just fill out whatever you can. Do your best. Forget the rest. So I do want to give a tip on the domain, and then I want you to talk with your classmates and kind of compare. For the domain, now I know the window only shows this much, right? It only shows it goes from -5 to 5. But the fact that it goes to the edges of the window that I drew here means that it continues on and on and on forever to the left and down and on and on and on forever to the right and down. When I talk about how that looks along the x-axis, right, that's going to go forever to the left and forever to the right. So my domain is going to be -infinity to +infinity. And for so many of our functions, you're going to see the same domain. Not for every single one, but for the vast majority of them, you're going to see from -infinity to +infinity for the domain, not necessarily for the range. But you're going to see that over and over again. Okay. Take a minute or two and chat with somebody, compare some answers. Maybe they got something you didn't get, and then I will give you the answers.
I got the domain. You just gave it to us. I can give the range. I'm guessing on my range. I'm guessing it's this. Oh, I don't have and then I got the x-intercept because that's where it crosses. It's -2, 0, and then 2 +0. Okay. And then my y-intercept, whatever.
Because that's like on the axis or whatever. So it's -0 and then 2, 0. And then it's like the opposite. Yeah. Because it crosses the right as daycare.
What's that? So these are the negative numbers. This gets more negative, right? -2, -4, -100, -1,000, -infinity. Yeah. You're not done. It's good. It's a good question, right? We're going to experience infinity a lot more in this class. So great topic to understand. Okay, let's do a check-in here. I've got the domain already. My range is going to be from -infinity up to 2 with a square bracket. Check that square bracket, right? So the range when I'm talking about the y values, if I smush this onto the y-axis, this goes down forever and ever and ever, and it comes up to 2. It includes 2, but it does not go beyond that. Domain and range, those are intervals, right? They're sets of numbers. X-intercepts and y-intercepts are just coordinates. So x-intercept is going to be the points where the graph crosses the x-axis. And the y-intercept will be the point where the graph crosses the y-axis. Hopefully you got those or got close. All of these should be round brackets or round parentheses because they are coordinates. Or points. Keep it simpler. The interval where the graph is positive. That's where the graph is above the x-axis. So above the x-axis is going to be this portion here. So what interval is that? If I smash that back on the x-axis, that's from -2 to 2. Now, the graph is not positive at this point. It's neutral because it's not above the x-axis. So I go from -2 with a round bracket to +2 with a round bracket. This is going to take some getting used to, and you'll get better the more we do it. I don't expect 100% of you to understand 100% of this lesson today. That's why we practice. That's why we ask questions. Now, negative is going to be everything else. So negative is going to be what's below. Now, it always feels easier to do the positives first. Like the right-hand side is easier for me. So it's going to be everything after 2 over to infinity. But then it's also going to be everything from negative infinity to negative 2. It's going to be this section. So I have negative infinity to negative 2. Union 2 to infinity. I'm going to pause there. There are questions, challenges, things I can re-explain. Yes.
I don't really understand how you get the negative part. Like of the
For this side?
yeah.
Do you mean the negative part, like the negative interval, or like the negative infinity part?
The negative interval of the equation.
Okay, so when I'm talking about the negative interval on the graph, I'm looking for the part of the graph under the x-axis. So I could highlight these in another color. What color is not going to look terrible on top of red? I don't know. Brown's not going to look terrible on top of red. I don't have brown. Brown's not an option. How about pink? Pink. Okay. So this is where the graph is negative. So the graph is negative at -3 and -4 and -5 and -100 and -1,000 and negative of infinity, right? All of those values are going to be underneath the x-axis. So from negative infinity all the way up until -2 is a negative interval. On this side, it's negative at 3, it's negative at 4, it's negative at 5, it's negative at 10, it's negative at 999. So it's going to be from 2 all the way to infinity. Does that help a little? Maybe. Okay. Increasing and decreasing. Increasing is going up as you walk across the graph to the right. So I always enter left to right, just like I read a book. So I walk on this graph, up, 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 up. That's increasing. Down, 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 down. That's decreasing. So what is this interval? Now, this tends to be the part that catches most students. Remember that this interval is smashed on the x-axis. So what are these x values? Well, that's negative infinity all the way to 0. 0. So from negative infinity to 0. Where is it decreasing? So from here to infinity. So from 0 to infinity. To infinity and beyond. Toy Story fans? No? Okay.